Unit 7, Probability and Statistics, starting out with probability for this week. Section 10.4 is we talk about how do you find the probability if one event or the other happens. So there's two possible ors. So you know how if you say, do you want like cream or sugar with your coffee? That could mean you just want cream or you just want sugar, but is it possible to have both cream and sugar? So even some people have that. Okay, so just because I said cream or sugar doesn't mean they're mutually exclusive. There might be overlap. You might have both, right? So there's two cases when you use the word or in the English language. It could mean mutually exclusive, one or the other with no overlap, or there might be overlap. The one with no overlap is the formula of the probability of A or B is you simply add the probabilities, and that's easy to remember. You won't get this formula on the quiz, but it's pretty easy to remember because would you expect the probability to be higher or lower if you have the probability of one event or another happening?
Higher.
Higher, right? Because if event A happens, then it's correct. If event B happens, it's also a true situation. So you have more likelihood of it occurring. So of course you're going to add. Now the thing is though, you have to be careful about subtracting overlap. So right here, we're going to do examples in a second, but some people don't play cards that often. So I drew a picture here, and since you don't have color on your worksheet, what color are the spades? So if you're not familiar with, you have to be very familiar with a deck of cards. So why don't you in the margin write black for spades, and what about clubs? Yeah, write that, and then for hearts are red and diamonds are. So I would make a note of that. How many cards total are there? 52. So make a note of that. There's 52 total. How many in each suit? 13. So also make a note of that on your. So there's 13 in each suit, right? 13, 13, 13, and 13, and they add up to 52 without jokers. So there's 13, 13, 13, and they add up to 52. How many are red? 26, right? Or one half. 26 out of 52 are red, since there's 13 of each suit. Okay, so let's do some examples together then. A card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. All right, selecting an ace or an 8. So what you have to ask yourself is, do those overlap? Is there such thing as an ace of 8s? Okay, so are they mutually exclusive or overlapping? Mutually exclusive, right? So we're going to use the formula for this. Probability of A or B is you add the probabilities together. So we will do, what's the probability of getting an ace? There's 4 aces, right? So 4 out of 52. What's the probability of getting an 8? There are 4 8s, right, in the deck. There are different suits, but there are 4 8s. You can see those right here. There's 4 8s. So that's 4 out of 52. So the probability of selecting an ace or an 8 is, you're going to add the fractions. And I do not want you to worry about simplifying these fractions. Often we like to look at probability with a decimal anyway, which you would do on your calculator. So just leave it like that. We're not going to waste time on that. So what about selecting a 10 or a diamond? Is that mutually exclusive or is there overlap? There's overlap. So we have to be careful because there's such thing as a 10 of diamonds, right? So using the formula, it's probably A plus B minus the probability of A and B. So what's the probability of getting a 10? Right, there's 4 10s, so 4 out of 52. What's the probability of getting a diamond? Good, there's 13 diamonds. Now here's the interesting part, we subtract the overlap. So what's the probability of getting a 10 of diamonds? Yeah, there's only 1 10 of diamonds, so it's 1 out of 52. So our answer is just fractions, right? The denominator stays the same. 4 plus 13 minus 1. Yeah, and we're going to leave it like that. Questions so far? Okay, so let's try a 6-sided die. Okay, assuming it's a fair die, it's not like loaded or anything or weighted. What's the probability of rolling a number greater than 4 or even? Is that mutually exclusive or is it overlapping? It's overlapping because greater than 4, what are the numbers greater than 4? On a die, it's 5 and 6, and one of them is even, so we have to use the formula for overlapping. So we do probability of A, which is a number greater than 4. What's that probability? Nice. What's the probability something's even? On a die, how many even numbers? There's half, so 3 out of 6. And now we have to get rid of an and, so greater than 4 and even. How many of those? What is it? Yeah, there's only the 6 is greater than 4 and even, and there's one outcome. So 1 out of 6, and so we get 4 out of 6, right? Great. And now we're going to do, this is particularly tricky one. So we're going to have to use the full formula here. So there's 100 students surveyed, okay? 92 own either a car or a smartphone. But there could be overlap there. They could be both. Also, 65 own cars and 82 own smartphones. What's the probability that a randomly selected student owns both a car and a smartphone? So we're going to use the whole formula, and then it won't be that tricky. So if we let A be, we'll label this above. A is owning a car, okay, and B is owning a smartphone. Because let's label the events. And we're just going to basically use this formula. The probability of A or B equals, I'm copying it from above, the probability of A plus the probability of B minus the overlap, which we've just practiced using several times. I want to copy it because I'm going to replace it with values and solve an equation, just like a regular linear equation. So you tell me, what do we know, and if you read the problem again, what are we trying to find, first of all? What does the question ask for? Yeah?
How many students have both a car and a smartphone?
Okay, so is it, which of these does that correspond to? Own both a car and a smartphone. It's this one, right? Probability of A and B. So that is the unknown. So we don't know that. We're going to solve for that. What about probability of A? Or not even the probability, but how many own cars? Remember, A is how many own cars? 65. We could be dividing all these by 100, but we don't need to worry about that. What about probability of smartphone? Yeah? And what about probability of A or B? Or just not even the probability, the number of students that own either a car or a smartphone. Very good. We're gonna put our final answer over 100. So don't worry about that. If we just solve for x, this is minus x. We solve for x, we'll have it. Okay? So you would add these together and subtract them from 92. So you get negative x equals negative 55. If you add 65 and 82 and subtract it from 92. Say again? Yes. Yes. So over here, so I get 92 equals 65 plus 82 is 7147 minus x. I'll go this way for a second. And then I subtract 147 from each side. So x is 55, and that's the number of students that own both a car and a smartphone, and we just put our final answer over 100 is the probability that a randomly selected person. Yeah, Brian.
Is it okay to simplify those though?
It's if you want to. What I really want you to do is whatever the book does, so that you can compare your answer. So you check what the book does. I'm not sure. And then I just want to show you this, just so you get an idea of how this works. I want to show you the Venn diagram of the same situation, just so you can see it. If A owns a car and B is a smartphone, this is how the numbers break out. There are 100 total students. 65 own a car, 82 own a smartphone, but the overlap that you just found is 55. But if you add up the numbers, 10, 55, 27, and then 8 poor students here do not own either a smartphone or a car. Okay. So if you add these all up, though, there are 100, and that's sort of what it looks like. Okay, so let's go on to 5. So then, here's another part of your notes. Sometimes probability is easier to calculate if you do the opposite. So instead of finding the probability something occurs, you find the probability it doesn't occur and subtract it from 1. So these will go quickly. The symbol is not. You put a little bar over the front, not. So what is the probability of not? If the probability of some event occurring is 0.45, what's the probability of not A? Well, it would be 1 minus 0.45. So if this is a new, we don't have a scenario or anything, just if the probability of A is 0.45, that's given. And you want to find the probability of not A, that would be 0.55, right? Yeah, it always adds up to 1. So like if the probability of it raining tomorrow is a 45% chance, then the probability of it not raining is a 55% chance, right? Okay, so what about this? If the probability of A is 1, what's the probability that A does not happen? Exactly, 0. 1 minus 1 is 0. So that was 1 minus 1 equals 0. And then this would be, what would be the answer here?
0.
Yes, 1 minus 0.03 is 0.97. So that's called the complement. And so this is the last thing we're going to do. We're going to use that fact to find the probability here. So let's say I want to know the probability the card is not a 7. What I do is I do 1 minus the probability that a card is a 7. This comes in handy in other situations, even more so than this. So what is the probability the card is a 7? How many 7s are there in a deck? 4 out of 4. So it's just 1 minus 4 over 52, which is just 48 over 52. You get a common denominator of 52 over 52 and subtract. So the probability it's not a red card is 1 minus the probability it is a red card. So probability a red card is? What's the probability that you draw a red card? A red, oh, I'm sorry, yeah, a red face card. So how many red face cards are there? Face cards are Jack, Queen, King. I think 6, right? There's 6. So red face card. There are 6 of them because it's hearts, Jack, Queen, King of hearts, and Jack, Queen, King of diamonds. Aces are not face cards. Yeah. So aces don't count. Okay, so in the 2 red suits are hearts and diamonds, right? And the face cards are Jack, Queen, King. So that's a total of 6. Yeah, just red. So you get 52 minus 6, or 46 over 52 it should be. And you can just leave it like that. Is that right? I think so.